Okay, so this is another Higgs video. This is Hessian electronic structures, Higgs ACES 3, quantum nucleon, Meson Quarks photons. Those are the topics in the video. August 16, 2012 is what I'm referring to for the data, for the cross-referencing of the WOW data. Today is September 29, 2012. Line 18A3W4, uranium neutrino split Z bosons, weak atomic 5G UFO WOW SETI, cross-referencing. I'm going to Google the Dec-Bin-Hex conversion calculator and www.mathisfun.com. It comes up there. So the hexadecimal is 128BFCC. The decimal is 19447756. So I'm going to Google 128BFCC and separate it. On August 16th, my thoughts. Okay, so new data comes up in relation to a computer program that is acquired in the UFO design. It's called ACES 3. So, quote, new data, jchemphysics dx.doi.org, and there's the number for it. Parallel implementation of electronic structure energy, gradient, and Hessian calculations, and there's the people that worked on it, scientists. Gainesville, Florida. Received in 2007, published in 2008. ACES 3 is a newly written program in which the computationally demanding, well, I think it's unique that this is coming up because if you remember in the previous video, we're talking about designing a computer program so you can simulate your Higgs experiments before you actually build something and prove it, right? So you can save money that way. This is cool that this came up right after that. So obviously this has something to do with it, okay? So ACES 3 is a newly written program in which the computationally demanding components of the computational chemistry code, ACES 2, J.F. Stanton Quantum Chemistry Program, University of Florida, blah, 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 has been redesigned and implemented in parallel. The high-level algorithms include Hartree-Fock, self-consistent field, second-order many-body perturbation theory, energy, gradient, and Hessian and coupled cluster signals, doubles, and perturbative triples, energy and gradient, which I have no idea what all that means. So, for SCF, MBPT2, and CCSDT, both restricted HF and unrestricted HF reference wave functions are available. For MBPT2, gradients and Hessians, a restricted open shell HF reference is also supported. The methods are programmed in a special language designed for the parallelization project. The language is called Super Instruction Assembly Language, SIAL. The design uses an extreme form of object-oriented programming. All compute-intensive operations such as tensor contractions and diagonalizations, all communication operations and all input-output operations are handled by a parallel program written in C and Fortran 7.7. This parallel program, called the Super Instruction Processor SIP, interprets and executes the SIAL program by separating the algorithmic complexity in SIAL from the complexities of execution on computer hardware in SIP. A software system is created that allows for very effective optimization and tuning on different hardware architectures with quite manageable effort. Again, that's a quote from American Institute of Physics. And there's all the different topics that they cover in that. Real quick, and that's at jcp.aip.org, okay? There's their end publications. www.qtp.ufl.edu. So the keyword Google is Quantum Theory Project plus ACES 3. So I put those two together and this is what comes up. So this is known are fixed values, unknown are variable values, and sample space. And it shows the event. So there's a quantum physics, the nodal theory, a Hector C. Parr, chapter 3, probability and quantum amplitudes. Quotes. 3.11. We can illustrate these facts on a diagram. The initial conditions or the given situation may be represented as the values of n variables h1 to hn. We suppose that the first MOF, these, e.g. the size and shape of the dice, are held constant during all the trials, while the others, the position and speed of the throw, are allowed to vary unpredictably. The throwing dice. I don't know what that has to do with anything, but oh well. This is what comes up, so it's going to have something to do with something. Thus, xm plus 1 plus xn are the hidden variables. And if we deny the existence of these in quantum situations, all the variables are fixed. We represent the outcomes of the trials by y1, y2, and the set of all possible outcomes, in this case 1, 2, 3, 4, 5, or 6. We call collectively the sample space. The event E, the throwing of an even number, comprises a particular subset of the outcomes 2, 4, or 6. We often need to multiply probabilities together. If A and B are independent events, then the probability of the combined event A and B is found by multiplying together the probability of A and the probability of B. The probability of drawing a red card from a pack is half, and the probability of drawing an ace is 1/13, and so the probability of a red ace is 1/2 multiplied by 1/13, which comes to 1/26. It can easily be seen that the same rule applies to quantum amplitudes. We can find the amplitude for a compound event when we know that for each separate event by multiplying together the two amplitudes. And then if we want the probability of the compound event, we just square its magnitude in the usual way. In fact, it does not matter whether we multiply the magnitudes and then square the amplitude or square the two separate amplitudes and multiply, for it can be shown that z1 times z2 when I look at Z, I think of the Z boson, right? The Higgs boson. There's the Higgs boson. Z1 squared equals Z1, 2 and 2. So, www.hectorparr.freeuk.com. So the formula idea from the data found in the Google search is the Z boson 1x 1x to the Z boson times Z boson 2 to Z degrees protons equals Z boson 2x. What is x? 2 boson 2 equals 2Z degree protons. The 2 protons left over from the Higgs boson experiment, success 18 June 2012 at CERN. Look at the standard model for x. Under bosons on the chart we have W, Y, Z, but no x. X is the Higgs particle. So you have W for W boson, X for the Higgs particle, and then Y for photon, and Z for Z boson. So W plus X plus Y plus Z boson. Google WX plus Y plus Z boson, and it says X and Y bosons. Keyword Google Z particle. The Z particle, massively electrically neutral carrier particle of the weak force that acts upon all known subatomic particles, is the neutral partner of the electrically charged W particle. The Z particle has a mass of 9119 gigaelectron volts, nearly 100 times that of the proton. The W is slightly lighter with a mass of 80.4 GeV. Both particles are very short-lived, having lifetimes of only about 10 to 25 seconds. Is that it? So we're trying to create a particle that lasts longer than that. According to the standard model of particle physics, the W and Z particles are the gauge bosons that mediate the weak force responsible for some types of radioactive decay and for the decay of other unstable short-lived subatomic particles. So that's from www.britannica.com. So WZ particles equals gauge boson. There's the Higgs boson. Gauge bosons are Y photons plus G gluon plus Z power of 0 plus Z power of 1 plus W boson plus W plus minus power of 1 plus W power of minus plus W power of plus Higgs boson plus force. Sorry, I don't know how to make those symbols yet on my keyboard. What happens when you mix all of the gauge boson particles together? Just wondering. Still need to figure out what X means. I keep getting X as the electron volts. Okay? So, and when I'm thinking about X there, I'm also thinking of the Mu2e particle that you guys are working on, transferring the mu onto an electron volt. I wonder if that's got something to do with it. Interesting. Okay. Thanks for watching. I'm going to go on to another Higgs video.